We're going to start out with a little clip that was on WLOS, in case you missed it. God, I hate that.
Tomorrow marks 50 years since the launch of Apollo 11. Of course, that led to the moon landing that will go down in history.
A Hendersonville man was part of the launch team that helped pull off what once seemed impossible. News 13's John Lee has the story in tonight's Carolina Moment.
5, 4, 3, 2, 1, 0.
July 20th, 1969.
Liftoff. We have a liftoff.
That was an awesome day.
The Apollo 11 mission's Saturn V rocket took off many, many moons ago now.
The greatest adventure that this country's ever embarked upon. And it's a beautiful, beautiful sight when you're seeing it going up in the air.
George Knudsen says it sure doesn't feel like a half-century's gone by.
I can't believe it's been that many years since we did it. So all of us that did that got one of these.
He was part of the launch team for that memorable mission. NASA's Apollo Achievement Award went to those who had a hand in history.
I was in the firing room for that launch.
Knudsen was in the Launch Control Center,
culminating in Apollo 11's successful achievement of man's first landing on the moon.
Long before the summer of '69, it took 7 years of development.
There I am in 1963, see?
George worked as a flight test engineer for North American Aviation.
But these are the 5 liquid hydrogen engines being fired. And this was up in the mountains in Santa Susana, California.
The Saturn V used 3 stages.
That's the stage I worked on, the second stage.
A number of companies worked on different parts of it under extreme pressure.
All of that was done in parallel, and they were all brought together and integrated at the Cape in the vertical assembly building, the big tall building down there. And it worked.
On the day of the launch, he collected signatures to mark the occasion.
John Glenn Jr. right here.
In the moment, he says, making history wasn't really on his mind.
You know, we were so damn busy doing our part that it never occurred to us.
Days after the launch, the moon landing captured the nation. It was like an impossible dream come true.
It was an immense feeling of pride within me when that happened. And it wasn't just me, it was all of us. And it was nationwide. We were proud of what we did. And rightfully so, you know, that was quite an achievement.
George is 86 now. Many of those who played a role in the Apollo 11 mission are gone. But he wants younger generations to understand the magnitude of the achievement.
I think it's important that it not be forgotten that we did that. And you know, the kids coming up nowadays, they've got a clue.
Tower cleared.
5 decades later, we count down to the anniversary of the mission. To George, it proved Americans can do anything when we work together.
They've got the flag up now. And you can...
In Hendersonville, John Lee, News 13.
Just in case you missed it.
You were much younger then, huh?
I was. Okay.
All right, it's all you, George.
Forward. There we go. That is the Saturn V. I think this model. This was actually a flight model that Nixon canceled. That's the first stage. That was built by Boeing, and in Mississippi. It was assembled in Mississippi. It had 5 F1 engines, which they were 1.5 million pounds of thrust each, so it was 7.5 million pounds of thrust on that stage. And it burned kerosene and liquid oxygen. Second stage is the one I worked on. That was unique. This has never been done before. That burned liquid hydrogen, liquid oxygen, and 5 J2 engines. Nobody's ever fired 5 liquid hydrogen engines ever in history before. We did. The third stage, built by McDonnell Douglas, also used a J2 engine and used liquid hydrogen and liquid oxygen. What's the purpose of the 3 stages? The whole idea here was, this This baby burned for 2.5 minutes, then we got rid of it. So that reduced the weight that we had to put into orbit considerably. Weight is always a consideration. And then my stage fired. They had to do it all by itself. You know, no help from us anymore.
How long did that burn, George?
It burned 6 minutes.
6 minutes.
Now, the second one we ever launched, which was unmanned, we were partying in a boat out on an island watching it go, and 6 minutes went by, and 7 minutes went by, 8 minutes went by, 9 minutes went by, and I turned to my partner and I said, geez, something's wrong, you know. And sure enough, something was wrong. We got done there, the launch is over, we got back in the boat, finished the whiskey, and we get home to do some more partying, and get a call from the big boss and said, man, we had a problem, you gotta come in and analyze data. And I said, okay, Andy, we'll be right there. He said, no, on second thought, why don't you come in early in the morning? And sure enough, what happened is 2 of the engines shut down prematurely, and it ran on 3 engines, and it still performed flawlessly. It just burned longer, okay? And it worked. And the third stage, its job, after we burned out in 6 minutes, this guy fired up. And this is the guy that put this part, the Apollo stuff, into Earth orbit, okay? That went into Earth orbit right there. This stage still attached to it, because once it got into Earth orbit, and we waited for a full moon, you know, if you're gonna go to the moon, you wanna see it, right? That's a little bit of a, I just wanted to see if you're awake. Anyway, the third stage then fired and put it in what we called a translunar injection. In other words, it broke the bonds of gravity of the Earth and sent it on off to the moon, and then it was disposed of. But in the front part of the third stage was where they stored the, up in here, where they stored the LEM. So they had to turn around on the way to the moon, pluck it out of there before they got, you know, and then they abandoned the stage. So that's what that's all about. That's the background. This all started back in the 30s. Now that's a German A4/V2. That rocket was basically designed by Wernher von Braun. Now Wernher von Braun always wanted to go into space, always wanted to go to the moon, and when he was still a student, he was in one of the rocket societies in Germany, fooling around with rockets, and that's how he got involved with the Army Ordnance Division, building a ballistic missile. Okay, and that's a fascinating story too, if you want to read about it. But anyway, that was his first successful rocket, and that's what it looked like. It burned alcohol and liquid oxygen. It had a single engine. It had carbon steering vanes at the bottom.
That wasn't the V2, was it?
That is the V2.
It is the V2.
Yeah.
Okay.
Yeah. And there's the man right there. It was all his dream. He's also the father of the Saturn V. And we've seen that picture. We know that young man right there in the middle. This is up in Santa Susana Mountains. This is in the background, and you'll see a picture of it later, is what we call the battleship test stand. That was a big stainless steel thermos bottle. And the whole object of this was to test fire our engines, get the procedures down right, develop the ground support equipment, develop the procedures for servicing the engines, servicing the tanks, inerting them after, you know, when we had to abort, you drain the tanks again. Well, if you drain the liquid oxygen, liquid hydrogen tanks, and they're gaseous in nature in there, you got your bomb on your hands, a big bomb. So I had to develop a procedure to get those tanks inert. Oxygen was easy because I could use nitrogen gas and displace the gases. Hydrogen was more difficult because it's so damn light, it'll hide in nooks and crannies. And so we couldn't just purge it out. We couldn't just flow gas through and purge it out. So we came up with a scheme of pressure dump, pressure dump, pressure dump. And that reduces the partial pressure of hydrogen every dump. You know, we go up like 4 or 5 atmospheres and then blow it down. 4 or 5 atmospheres, blow it down. And each time reduce the amount of hydrogen. That way we got a good mix. We got rid of the hydrogen gas. Liquid hydrogen is at minus 423 degrees Fahrenheit. That's damn near absolute zero. Liquid oxygen is minus 267 degrees Fahrenheit. That stuff is really tough to deal with, particularly hydrogen. Hydrogen will get out of anything because it's just one molecule. And man, to contain it is a real trick, a real problem. In fact, one time the first time we ever were firing a single engine on that battleship, you see way up in the top up here is a burn stack. Where's my pointer? Right there? That's a burn stack. And we collect the leaky hydrogen out of these flanges and other interfaces and run it up the burn stack. Well, we didn't burn it in the early days. We said, what the hell? It's light. It's so light it'll just go in the air and dissipate. Bad plan. One night we were firing an engine and there was a temperature inversion and the hydrogen gas went up and layered underneath it, found an ignition source somehow, and kapow! Huge free air explosion, and we leveled all of the pretest buildings, which were metal buildings, you know, pre-engineered metal buildings were all flat as a pancake. The vehicles destroyed. From then on, we had propane going up there, and we burned all the time. We learned a lesson. That's it. That's the very first time we ever fired 5 liquid hydrogen engines. It's the first time it's ever been done in the history of the world. And man, it took us 4 days to get that one done. And we just slept in a blockhouse. Damn boss would go to McDonald's and bring, you know, garbage for us, and we'd eat garbage, we'd sleep there, and we just kept on going until we got the job done. And since then we rebuilt the buildings in the background, as you can see. But, you know, when you think about it, that's a perfect engine, isn't it? Because we burn hydrogen using oxygen. And what do you see shooting into the flame bucket? Water vapor. That's a perfect engine. Yeah. Another thing about, you go on that test stand or you go out on the launch pad and you got hydrogen on board, you can't see hydrogen burn, okay? So all of us guys carried sand in our pocket. And we'd walk along and we'd throw sand out in front of us because if it hit the burning hydrogen, it'd flare yellow. And we'd say, whoops, I ain't going there. And it worked. None of us got burned.
Hey, George?
Yeah.
How did you ignite that out in space?
We'll get to that. I'll get to the engine.
Sorry.
Yeah. There it is. There's the stages, okay, and you've seen that before. That was my home for a number of years. I got there before that even started out of the ground, okay?
They've renamed that now, George.
What do they call it now?
Vehicle assembly building.
Yeah. And this, if I can find the pointer again. What the hell am I doing?
Out to
There we go. That's the Launch Control Center, okay? There's 4 firing rooms in there. There's 2 vertical bays in the vertical assembly building. And that's where we stack the rockets. Now these rockets sections have never seen each other before until they got to the Cape. Never. And all of the interfaces had to work perfectly. And we called it stacking. You know, we put one on top of the other, one on top of one on top of the other. And then the next step was we had to check out all the interfaces and make sure all the communications and connections were proper so that the instrument unit could talk to everybody. Once we were happy with that, then we had to install all the ordnance, and there's a lot of ordnance on there, primarily explosive bolts. Because to separate, we blew it apart up in space. That's how we separated it. So anyway, once all that's done, we'll show a rollout here somewhere.
I have heard that it would rain in that building.
So people rained on my parade in that building, but it never happened all the years I was in it.
Okay.
Yeah. That's just another diagram of the second stage. 5 engines on the bottom, and those fairings you see on the side there, those are the feed ducts for the liquid hydrogen, which is in the upper tanks, going to each engine. Okay, there's a cutaway of it. Liquid hydrogen, which is very light, in this stage up here somewhere. God, what a presenter. You can't.
It's the very end one.
How thick was that tank?
Well, not very thick, because we had a lot of problems with stress cracking. Because all the time that all of these were designed in parallel. I forgot to mention that. Everything was done in parallel. There's no serial time. So they came up with a metallurgy for this tank, and they fabricated the tank, and we had all kinds of problems with stress cracking in the tank. And so we'd have to go in the tank, the mechanics, and burnish out every crack that they found, so that when you load cold liquid hydrogen in there, you didn't get a And the other unique thing about this rocket is, hell, I'll just walk up there, it's easier. Is the common bulkhead here, okay? See it? Instead of 2 separate tanks, to reduce weight, the designers came up with a common bulkhead. Well, that's 2 aluminum layers with honeycomb material in between it. If that ever ruptured, it'd be Katie bar the door, okay? So that's unique. That's never been tried before either. But that saved considerable amount of weight. And why is weight important? Because the more weight we get out of here, the more payload we can deliver out into space. Okay? The other problem we had was insulation. The first foam insulation we tried on the outside of the tank would leak, because when you load liquid hydrogen, the tank shrinks. You know, Christ, it's going down to minus 400 some degrees Fahrenheit. And then we get air sneaking in there, and then we get icing, and then it'll pop off the insulation. And that was a big problem, because if it get too far, we're going to be all iced up. We won't be able to lift off. So the engineers out there in Seal Beach, some guy had a bright idea. This is surfing capital USA. Surfers know how to deal with foam. But they literally got surfers to come in there and apply the foam onto our rocket. And it worked. Isn't that something? There we are stacking. You heard me talk about stacking. That's the first stage. That's my stage going into the stack.
Hey, George? Did they have coolers in the stage to keep that cold, or is it just in there and then insulated? I mean, you pump it in, or?
You just pump it in.
And then it's not cooled beyond that?
No.
Oh, okay.
Now to load liquid hydrogen and or liquid oxygen, you go through what's called a chill down sequence. Okay?
Mm-hmm.
Which means you slowly introduce the cryogenic liquid and let the lines shrink and let the tank shrink and let everything try to come close to the temperature that it's going to operate in. Because if you went too fast, and I've seen this happen in the early days when we were in battleship, you got a pipe and you got a flange and you got a pipe, or you got pipe, flange, valve, and a pipe. Well, what happens? The pipe shrinks quicker than the flange. It's, you know, it's a heat sink, right? And what happens then? And you got a leak. Pulls apart, you got a leak. So we had to determine the optimum procedures for chill down without destroying our equipment. That was a lot of the purpose of the battleship program. That's a J2 engine. And the J2 engine is unique. It has 2 turbo pumps, okay, that pump the liquid hydrogen and the liquid oxygen into the engine, into the ejectors. So we, you know, they go into the combustion chamber, which is up in there. And light the fire, and away we go. But in order to start the turbo pumps, to start the pumping process, they're remote. They're on their way out in the atmosphere. We have what's called start bottles, okay? They're titanium spheres that I had to pack chilled hydrogen gas into, and I'll get to that in a minute. And inside that sphere was another sphere that I had helium in it. Helium was used as the operator to open and shut valves, run the gimbals and all that stuff. We used helium gas. So I had to store that in there. The start tanks was the real bugaboo. I had a piece of equipment on the launch umbilical tower that I used liquid helium in a heat exchanger with nitrogen gas. In other words, I ran nitrogen gas through liquid helium to bring the gas down to as low a temperature as I can get it, and then sent that into the start bottles, because I need to pack as much as I could get in there, because they're the babies that started the whole process up. They initially spun up the turbo pump, and then the gas went into what we call a gas generator, in which we introduced hydrogen gas and oxygen, and that burned, and that produced the hot gas, which ran the turbo pump continuously. You follow me? It's a bootstrap thing. Okay? We started it, and then it took care of itself, is what it amounts to. The tricky part was I had a temperature pressure envelope I had to meet on every engine for every launch. Okay? And I manually controlled it because the automatic control system never did work. It was based on trying to measure the depth of liquid helium in my heat exchanger. Well, you know, the thing was no taller than me. You don't have any differential pressure in there to deal with. So they never damn worked, right? So I always had to run it manually. I never once hit the pressure temperature envelope. And every time I got my ass chewed out, and every time I said it flew, didn't it? Because it was virtually an impossible task. And then if they went into holes, which we did often, then it becomes more of a problem, because what happens when you pump more gas into it under pressure? You got the heat of compression. So I'm heating the damn gas up when I'm trying to put cold gas in there. So I'd have to vent it down, try to repack it, try to hit this envelope, and it was a nightmare. But the thing we knew, my buddy and I, was from testing, limit testing in battleship, we knew that these parameters were nice to achieve, but they weren't necessarily true. So we cheated every time, and it worked every time. Every time. Yeah. The exhaust product of this engine out the nozzle is water vapor. It's amazing when you think about it. there we are. There's rolling out the first one. Now it's loaded with ordnance, and the crawler's underneath here, okay? That's a beautiful thing to see all by itself. And it takes that 3.5 miles out to the launch pad, just like that. There it is on the launch pad.
About 3 miles an hour. About 3 miles an hour.
Yeah, not much faster. You get bored trying to walk beside it. It's like a turtle, but it had hydraulics, so it kept it level, because once you go up that ramp, you still got to have it level because you don't want it going. It's ingenious. That's the firing room. This is where it all happened. So I didn't do it all by myself. I hate to tell you that. Not all by myself. There are lots of folks in there. And I'm in there, and I'm right there. You see North American logo on the back of my shirt?
I don't see your call letters.
Yeah.
Should have shaved. How much of that did North American build?
How much of what?
Saturn V.
Saturn V, North American built the second stage, all of the engines. They were built by Rocketdyne, which is a division of North American. And the command module and the service module, all built by North American. I'm going to pass around some of this stuff if you want to look at it. Here's the cover off the very first one we ever launched, okay? And if you look closely across the top, you'll see Werner von Braun's signature. To the right of him is a German by the name of Kurt Diebus, who also came over from Peenemünde. He was in charge of the launch operations. On farther down, you'll see John Glenn Jr., because he was in there observing what we were doing. The rest of the signatures are guys I've worked with in the firing room. So there's another memento. This is a little rinky-dink thing that NASA gave us for the guys that were in the firing room for Apollo 11. These are the patches that I wore on my jacket. And here's a picture of the battleship version that I talked about. Where am I on my list? Oh, I worked at Santa Susana until I think 1966, and then was transferred to the Cape and part of launch operations. And basically, my job at that point in time was to verify the installation of all my ground support equipment, which was considerable, and write checkout procedures, okay, and test everything, and test everything, and test everything, and test everything. Because we had a policy of 0 defects. You know, and a defect could be as small as the paint being scratched. And our policy was 0 defects, fix that paint scratch. And of course, the more serious problems, of which there were. And also write our portion of the countdown procedure. Because the countdown procedure is an integrated document with all of us contractors you see lined up here. These are Boeing guys on this side, North American guys on this side, and McDonnell Douglas guys on the side in front of us. And we were in charge of the engines. And these are all the hangers-on that didn't do anything because they didn't have any controls. I think they called them test conductors, but they couldn't test anything. We had the controls. And this is where von Braun and the bigwigs were, here and up there. And over here in the back, you don't see it, there's a little room where those guys are headed, where you go in if you got a problem to get your butt chewed out and explain the problem. And what I did for me was I had what I called a brain book, and I can't find it. I think it went by the board on a divorce. It's 3-inch thick binder, and I had every mechanical schematic, every electrical schematic that had to do with my equipment, both ground support and vehicle. A cutaway of every component I ever had to deal with, be it a valve, pressure switch, ad nauseum, all in the brain book, okay? Because I knew if there was a problem, I would be quizzed right away, and I didn't have time to go run and look at documents. I had to know what I was talking about. And so I spent in my spare time just going through the brain book, until I had the whole damn thing committed to memory. Anything went wrong, I could pull it out of here. And that saved my bacon a lot. There he is. That is after we launched the very first one, AS501. And that's before we partied hardy. And we did party in Cape Canaveral and Cocoa Beach and Merritt Island. I think I mentioned this before, but during the 60s in Brevard County, North Carolina, we had the highest per capita education rate of any county in the United States. We had the highest income rate of any county per capita in the United States. We had the highest alcoholism rate for every county in the United States. The highest divorce rate, every county in the United States. In fact, there isn't a single one of my friends that didn't go through a divorce because of the stress we were under. That's the AS501. See that? We launched it 2 November 1967. And those are my call letters, C2GP. And there it goes.
Hey, George, were you involved with any of the previous launches, like for Skylab later on, when they launched Skylab into space on the Saturn V?
No, what happened, us contractor guys had what I would call the right stuff. You know, we were allowed to kind of free run and get our equipment shaped up the way we needed to, make it work, do whatever was necessary, kludging if necessary. And then after we put the man on the moon, Apollo 11, NASA shut the door. NASA said, boys, you are going to go by the book. And I turned to my buddy and I said, you know what, Pat? This sounds like the beginning of the end to me. So Pat and I started looking for other jobs, and we both stayed until Apollo 12, and we left. And they went on, and there was 12. They went up to 17, and then Nixon canceled the last 3. And so anyway, and there was a big layoff. You know, we were damn lucky. I was able to give my house away. I had a beautiful house on the canal with a dock in the back and a boat and everything else. And I gave mine away, and I was just lucky, very lucky, because I didn't have anything in it, so I could give it away. Some of these other poor people had equity in it, and they were trying to recover equity, and you couldn't do it in those days, I mean. So I gave my house away. At the time, it was a $35,000 house. The last time I went over there, it had sold for $2.5 million. Why? Because this is Florida, and it was on a canal, and you can get in your boat, go through the locks of Cape Canaveral, and be in the ocean in a half hour. Well, they can't do canals in Florida anymore. That was outlawed. So the value went up because of the location, and not because of the structure. So I lost out on that one. But that's not the only thing I've ever lost out on. What else have I got to tell you?
You were going to tell us how you lit it, how you lit the motors.
Oh, okay. They would get a signal from the instrument unit that they're at the right place and time based on the gyros and all that good stuff. And then they would send, open the valve from the start tank to introduce hydrogen gas into the turbopump turbine to start the spin up, which then we would bootstrap because now we got some fluids flowing, and we tap off that and run it into a gas generator, and that would fire from spark plugs, okay? And then we had a configuration going, generating hot gas that would run the turbo pumps, of which are two, one for oxygen, one for hydrogen. And that's how they started. And the third stage had a real unique problem because they not only had to shut down, but later on in orbit, they had to restart again. So our engines, the J2, is restartable. And we're the only ones that restart like that of the liquid hydrogen, liquid oxygen series. Any other questions?
Did you guys ever use hypergolic fuels?
No.
No?
Do they still keep, I'm assuming they still keep all the records of all this stuff, like documentation and records and?
Let me tell you what happened. After the program shut down, particularly on the second stage, I know about that, all the specialized jigs, fixtures, welding equipment was all destroyed. Okay, so we couldn't make that stage anymore. Couldn't do it.
On purpose?
Huh?
On purpose?
On purpose. That's your government in action. And getting to the engines, we can't make that engine anymore.
Why not?
Because, no, all this stuff was sold to, Jeff, I think it was, help me out, Rocketdyne went to,
Rockwell?
no, that is, North American became Rockwell.
Oh, Thiokol?
No, Pratt & Whitney. They bought the J2 engine and the equipment to build it and subsequently destroyed that. Okay? The stuff for machining it and la la la. Because you design an engine, the critical part in the engine is making sure that you impinge the oxygen and the fuel correctly.
Did you want me to back it up?
Yeah.
You might be able to with that, I don't know.
Yeah. They got to impinge directly and mix properly in the combustion chamber, or you will get unstable combustion, which will gallop across the engine and destroy it. So that, you know, that design work is critical. And we had that problem on this engine, we had the problem on the F1 engine, but they all got solved. And now those solutions are gone. They're gone.
What's the replacement?
There is no replacement for that.
Yeah, I mean, the current, so there's current ones that are being built now, are variations of this?
To my knowledge, there's none that big anymore.
They're using Soviet engines. That
Well,
were
I think
stored
they
in the
quit that,
Ukraine.
didn't they, Jeff?
SpaceX.
Yeah, that SpaceX is making their own RD-180.
Yeah.
Russian.
But all our satellites and stuff on the Atlas V series were put up with Russian engines. We bought engines from Russia. Can you believe that? Because we can't make them. And they were good engines.
George, you know, another one, not on this, well, aerospace still. After McNamara was through with things, he had all the moles, you know, destroyed for the SR-71. Same deal. Same deal.
Yeah. You learn all this stuff and you destroy it. It doesn't make any sense. Interestingly enough, I think it was 2 years ago, I got a call from, I forget who it was, down at the Cape. They were trying to resurrect the J2 engine into what they call J2X. And the question was, how did you prepare that engine for launch? And so I went through the procedure with them. They didn't know how to do it. Now, I don't think they've progressed on J2X, have they?
I don't see it mentioned in Aviation Week anymore. They they basically got the bell working, they fired the thing, the gas generator worked and all that. They didn't build the electronics package yet. They were not doing things in parallel, everything was serial. So that's sitting in a warehouse somewhere as far as I know. I haven't heard it mentioned now for 2 years.
So we reinvent the wheel every time. And Elon Musk is doing a good job of that. You think about that. We threw our boosters away, but we had no choice because what did we not have that he's got? We don't have GPS in those days. We didn't have powerful computers in those days. And so we couldn't send them back to Earth other than, that's a lot of money tossed on the tube.
So George, the thing that kind of blows my mind is you did testing like at this site, for example, that's on the screen right now. And you also did, I mean, kind of the real world testing where you put the stages together, you set the rocket out and you fired it off. And it seems to me like there's a big difference between doing it here on Earth under those controlled, circumstances. It's not at altitude, it's not being moved, with all the other dynamics going on at the same time, all the other physics. How many full test runs could you do when you have a multi-stage rocket before you stick a person, a crew in the...
That was an interesting story, okay? Von Braun's theory, and his key to success was you tested everything a stage at a time. And NASA administrator says we gotta compress the schedule. We can't afford that luxury. We're going to stack it all up and we're going. Now that put a hell of a load on all of us, okay? Because what happens is the launch vehicle, the first stage is manufactured in Michoud in New Orleans, and it's barged over the Mississippi test facility, put in a test stand, and it undergoes a full duration test firing, okay? And now we say it's certified. The second stage is built in Seal Beach, California. It's loaded on a Guppy aircraft, flown to the Michoud test facility, put in a test stand, full duration test firing, it's certified. Same thing with the third stage, okay? All independent tests. They all get to the Cape and we stack them, one on top of the other. It's never worked as a stack before. It's never seen each other before. And that was the tricky part. And so we spent a lot of time in systems integration, if you will, making sure that everything talked to everything else, everything. The instrument unit talked to this, talked to the engines, talked to the ad nauseum, everything it looked at. And, and like I said in my interview, and it worked. Because we went all up, the very first launch, all three stages. Now to get to that point, part of the checkout is we do dry countdowns while it's in the VAB. Dry meaning no propellants. We fake the propellants. Then we take it out and put it on the launch pad. And then we do what's called the countdown demonstration test, and that's usually a few months before the launch. The countdown demonstration test is we go through the entire countdown all the way up to the point of starting the fire in the pot. And then we drain it, okay? And now we do that for a simple reason. We want to find out what's going to go wrong, because something always went wrong. And then we'd address those problems. Sometimes we'd have to redo the CDDT, sometimes not, until we got it flawless. And then we commit to a countdown and launch. And that took, I don't know, a couple of weeks. We're going in 14 hours a day, 7 days a week, doing all the stuff we had to do to get it ready, get it ready, get it ready, get it ready. The interesting thing, you want to hear anecdotes on...
Was that information when they talked to each other, was that like an analog current loop or some kind of a digital
I think it was digital. Don't quote me on that, because we did have some rudimentary, I want to find the launch umbilical tower. Anyway, my equipment was right here on the 180-foot level of the launch umbilical tower, okay? And one of the things we had on my level was a toilet, okay? And that was the only one on the lot. It was halfway between, you know? And I had a particular inspector that was always giving me a hard time and writing stuff up and just really ticking me off, you know? And here, I'm in the firing room running tests, and I'd change a procedure a little bit, he'd write me up. You know, because I didn't follow the procedure that I wrote. Oh, that'd tick me off, you know. And that was another piece of paper I had to clear, you know, blah, 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 blah. So I got sick and tired of it, and I told my technicians out in the stand, I said, now I'm dealing with 6,000 PSI gases. And you vent them, and it makes a lot of noise. And I told my technicians, here's the code word. If we're running the test, and Tom Smith happens to be in the toilet, you send me that code word, and I'm going to make the proper announcement. Like over the headset, I said, there's going to be a loud venting, 108-foot low in 6 minutes, pow! and he came running out of the potty, pants, there's underwear around his ankles, and something flew, and this flew, you know. And I got written up for that. That was another defect. They threatened to fire me, but they couldn't do that. Another interesting thing was I had, on my ground support equipment, I had 2 back-to-back regulators like this, you know, 6,000 PSI down to 1,500, down to some low level. But they're close coupled. And so they get to hunting, you know, but bing, 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 on, off. Bing, 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 bing. And they beat themselves to death. And I'd run out of spare parts. And I thought, Jesus, this is ridiculous. You know, we couldn't buy them fast enough. So I found a vacant room up in the high bay, and I built my own clean room because everything had to be locks clean. Okay. I built my own clean room, had air conditioners and filters and all that stuff, and visqueen all around. And I rebuilt my own valves because I could get the soft goods quickly, like the seats and the O-rings and this, that, and the other. Well, the big boss found out about it, and he chewed me out, the vice president. He says, you are not going to do that anymore. Yes, sir. That's it. I won't do it anymore. Well, I forget which one, we're in a countdown, and we're out of spare parts. The regulators failed, just like they always did. He says, you got to go in and fix that. I said, I can't fix it, Al. You told me you're going to fire me if I ever took anything into my own clean room again. He says, I'm ordering you to do it. I says, you're going to do it in writing. And he did. So that kind of stuff went on. That's kind of the right stuff attitude. You know, if you got a roadblock, work around it.
So what happened when you lowered the pressure with the argon? Was it argon? And you ended up with the end regulator, you ran out. What'd you do? Remember that story, Sears?
Oh, yeah. That was the helium hydrogen heat exchanger. Yeah, if any of you know what process control equipment is, you know, you use pneumatics to control valve positions and this, that, and the other based on sensors, right? Well, the air set for this particular piece of equipment always failed. I think it was the nature of the thing because it was such a cold environment. Anyway, I looked at it one day and I said to my tech, I says, you know, Dick, that looks just exactly like the air set on my Sears air compressor. I says, I want you to go down to Sears and buy all you can get your hands on, just so we got a backup. Well, after the Apollo fire where those guys got killed, NASA put in a new head guy, North American put in a new head guy, and things really got tough, okay? Really tough. Well, NASA sent in a colonel by the name of Rocco Petrone. And boy, you don't ever want to lie to Rocco, because he's too smart. He's been down the road. So anyway, I got caught, my vice president calls me into a meeting with Rocco to explain what the problem is. Because the word got out that I cheated. They used the Sears regulator. So Rocco, he's ripping me a new one and blah, blah, blah. And I said, well, Mr. Petrone, I'd written numerous letters, and I got them right here, to your NASA counterparts, explaining what the problem is and that we need to do something. They're either redesign it or forget about it, one or the other. And he looks over at the NASA guy, and he says, did you get those letters? Yes, sir. And why wasn't I informed? So the heat was off me and onto this guy, because I'd blown the whistle on the problem. And I got, Rocco remembers me because I was at the 25th reunion of this launch at my vice president's house in Cocoa Beach. And he became good friends with Rocco, and Rocco remembers me up until he died. So that was nice to hear. Hopefully in a positive sense. Anything else?
How'd you get into this? I mean, you go to college and say, hey, I want to work on rocket engine? Or what? I mean,
I was at sea on the USS John Paul Jones when Sputnik went up. And I had the mid-watch. I was up on the bridge. And we knew the path it was going to go over. And I got the long glass out and I saw it. And I said, I'm going to be a part of that. And that was back in 1957. And so that's what I did.
My question, I guess the basis of my question is the very often seen picture of the control room with all those people sitting there with that many glowing screens.
Yeah.
I think at that point my question goes into the mathematics of the whole thing. And by that I mean you have fundamentals saying detect, correct, prioritize, and time.
Yeah.
There's probably more options beyond that. Is that the basis of that number of screens that what is detected can be spread out over room full and the prioritizing brings it all together somehow?
Yeah.
It was because of what our abilities were with a computer in those days.
These guys along here, along this row right here, this row there, and that row there, the guys that had the screens and were doing the stuff, the manipulations. The countdown tells you when you're going to do certain things. All of that stuff basically is analog, okay? The guys beyond that are all instrument guys recording stuff and strip recorders and event recorders and all that kind of stuff. And these guys were, I call them feather bedders, you know, because they just got in the way.
Early version of the packet system.
Yeah. Anyway, that's about it, right, Dave?
Yeah, more or less. So if you had it all over to do again, George, would you do it all again?
Absolutely. That the esprit de corps of the people involved in this program in the 60s, and I think they figured out there was 450,000 people nationwide involved, from janitors to these guys to ad nauseum, okay? The esprit de corps to do everything right and meet Kennedy's deadline of putting a man on the moon by the end of the decade and returning him safely to Earth. We were committed to that and nothing else. I mean, the whole Vietnam thing and the Kent State thing, all that went on around us. We weren't even aware of it. We were focused. And I've never had that sort of esprit de corps ever, before or since. And it was an awesome experience.
Did you guys get a lot of support in the form of money? If you needed something, you just wrote a check and kept going?
Not quite. That's why you cheated once in a while.
Oh, okay.
Yeah.
That's where Sears came in, huh?
Yeah. It was interesting, when I got sent there from California, I got what's called swamp pay. I got extra money for going to Florida because it was a mosquito-infested swamp. And then they had a problem as we built up and more contractors came, more and more people. My God, what are we going to do with these guys we gave swamp pay? We can't take it away from them.
That was worth the money.
Yeah. So they figured out a way to fold it in and sell it.
So my question, George, is did any of your equipment on the aircraft have any vacuum tubes in it?
No.
No. It was all solid state if it was electronic equipment?
Yeah. A lot of relay logic.
A lot of relays, yeah. And then what about batteries on the aircraft? Did you guys have batteries of some
In the
kind?
instrument unit, they had batteries to power the electronics and the control systems and the gyros and spark plugs, stable platform.
Fuel cells.
Huh?
They used fuel cells, didn't they?
I didn't hear
They
you.
used fuel cells, didn't they?
Fuel cells?
Yeah.
Fuel cells on the
On the left.
on the
On the command module?
command module, service module,
Yeah, 'cause that's
LEM,
that's what
fuel
flew
cells.
on Apollo.
We had batteries on the Saturn V.
So did you top them off while they were on the ground? And when you-
That was IBM's job.
Oh, okay.
So George, like as precise as everything was, when they first put like the second stage on top of the third stage, were you sitting there thinking, I hope it fits? You know, like, because you never put them together before, right?
No, but what's embarrassing, there was a very embarrassing, and I couldn't find a picture of it, problem because the second stage was 18 months late. 18 months late. So the first stage is ready to go in the VAB and get checked out. The third stage is ready to get checked out. Command and service module is ready to go on the stack. There ain't anything in the middle. So North American built what we call a spool piece. Flange on top, flange on bottom, cables are ran through so they could talk to each other without us interfering, you know. And we sat there with this yellow painted spool piece for months and months and months waiting for the second stage to appear. And we were a butt of a lot of jokes. Believe me.
So what was the success rate of having all the bolts line up and all that stuff when they finally got that together?
100%.
Really?
Yep. The Saturn V rocket never lost a payload. The Saturn V rocket never, ever lost a payload. We had 100% success. 100%. None of the rest of them have been able to do that yet.
Yeah, good, George, thank you.
I understood most of it, George.
I told you I'd bore you, Alice.
Well, that's excellent. George, thank you so much for another fantastic insight into what was going on. I appreciate that very much. And if you guys have any additional, yes, ma'am?
I'd like to know if he's written all this down.
You just heard it. It's now documented on video.